Okay, here we've got our question about a geometric series, and you will find examples really quite like this in your notes. But to get started, you need to, having identified it's a geometric series, pick out sum to infinity, so that gives you one formula from page 8 of your formula book, and then 4 times the first term of the series. There's a standard letter that you use for first term of a series, and we need to do 4 times that letter, and we need to say that the expression on page 8 is equal to 4 times the sum of the first term of the series, which gives you an equation you need to solve. Now, although that's got 2 letters in, it will be A and R, it's possible to divide both sides by A so that you'll be able to end up by proving that, to show that question, so we need to end up with R equals 3/4. That will be your end point for 3 marks. Now, if you couldn't do that, you've got a great big re-entry point here. We know that R equals 3/4, so we can just carry forwards that value whether we obtained it or not. So now we've got 48, so that's the value of a different letter, the other one that you've been using. And we've got to find the sum of the first 10 terms, the sum of the first 10 terms. So once again, there's a formula on page 8 that will enable you to do that. You've got 3 values to put into that formula, and you've got to give your answer to 4 decimal places, so make sure you preserve that amount of accuracy. Then, part C, we've got the nth term being called un, and the 2nth term being called u2n. This again is a re-entry point. We've got the first term, we've got the common ratio. We're now dealing with the nth term and the 2nth term. There's a formula, again on page 8, for un. So you're just going to copy out that formula and replace the a's and the r's in it by the values you've got. For u2n, it's the same formula you've just done, except the n's become 2n's. So that's how you get these last couple of marks.